So welcome everybody. Let's today do some derivations. So here the derivations are. So first let's understand what is derivation. Here we know that the derivation of a function of a function fx of a function fx with respect to the variable x is a new function f prime x, which can also be written as d by d fx by dx. So or we can write or, which also can be written as d fx by dx. Okay, so now whose value at x is given, okay, that is we get f prime x is equal to limit tends to h tends to 0, and then we have a value f x plus h minus fx by h. So this is what the function starts with, my friends. So I know we have a object moving with a certain velocity, and its velocity at one point when changes to another point, then we go with these kind of derivations. So here f prime x is equal to limit h tends to 0, where we see that f x plus h minus fx by h. So my dear, if you are new or newcomers, then if you are learning first time, then just go for by having this so that you can solve so many of the equations or derivations. Okay, here we see f prime x which can also be written in different ways. Okay, it can be written here, you see, it can be written d fx by dx, we can write, or we can say fx f prime x is equal to limit tends to h tends to 0, where fx plus h minus fx by h. Okay, so now let's here we understand that if the above limit does not exist, we can say that fx is not differentiated into functions. So that's why here let's if we want to do this, we can solve some of the equations with this. Okay, so some of the equations we can solve with this. So let's go. I don't want to derive this for now. Let's go directly find the derivative functions for first principle order of the derivation. Let's do the first principle order of the derivations. First principle order of the derivations. Let's see. So find the derivatives from first principle or from definition. Okay, or from definition. So here we are going to just go for knowing 1x when we are taking it x, and then number 2 we are going to do the x square, and number 3 we are going to do the x cube, and then number 4 we are going to planning to do x to the power of n. Okay, so these are the things that we are going to do. So let's go with the first one with the thing y is equal to fx. Let's consider this is y. This you can consider y also, you can consider the other changed and variable also, like that. Okay, let's see now by adding the equation f prime x we know now. No, limit tends to where h tends to 0, and then we know fx plus h minus fx by h. So that's what we got in the above equation. Now let's see, let's solve this and see what we get. We are going to get it like here we get, let fx plus h is equal to x plus h. We have replaced this thing with this, okay, and then we know the first one here, fx is equal to x. Here we know what fx is equal to x and fxh is equal to x plus h. We will replace that over here and we get what we get is, this is just to know it. So we say limit tends to h tends to 0 when h tends to 0, then when limit h tends to 0, then what we get is f x plus h minus fx h. If we write it, oh sorry, I repeated the same. We can write x plus h in place of this, and minus x we can write in place of this, and then h. That will be when we write limit h tends to 0, we get x plus h minus x by h. So we get h by h. So that means we get what we get, limit tends to 0. I think if we are clear till here, my friends. If you have any problem with this, just you can just go for the comment. Now let's go the next step. So what it is, next step is, let's say limit tends to h tends to 0, we get h by h value, which is nothing but 1. This is nothing but 1. So now let's go with the second one. The second one is like, you know, we told let fx is equal to x square now. So that is fx plus h is equal to x plus h whole square. So this is because we told this, so we are putting square in both the sides. So now we get f prime x is equal to limit h tends to 0, we get, you know, f with the function is x plus h minus fx by h. Okay, now we go for limit h tends to 0. Now we replace this again. Now this one with this, we are replacing this with this. So we get x plus h whole square minus x square by h. So now if we go further calculations, so that's we are getting x square plus 2x h plus h square minus x square by h. So that means this one and this one cut. So we get, once again, let's see, limit h tends to 0, limits h tends to 0, what we are going to get is limit x tends to 0, then we get x plus h whole square. Yeah, we already got it here. So now we just see what we get, 2hx plus h square, we get this one by h, and that's nothing but limit h tends to 0, which is equal to 2x plus 0 is 2x plus 0. Okay, so we get equal to 2x. Obviously the answer is 2x. I hope I am clear, my friends. So here 1 h is cut off, so we took out the h's common, then we got, So yes, 2x plus h tends to 0. Yes, so when we told h tends to 0, like we took it out, this common h we took out, yeah, and then we got 2x plus h by h we cut this 2, we got this h is tends to 0, so we wrote replace h with 0, we get 2x. So our answer is 2x for this when we are doing fx is equal to x square. When we are doing fx is equal to x square, the derivation for the first principal order, or we can say from definition, we will get 2x. So wherever we get these functions of x square, we get 2x. Okay, so let's go with the other one, my friends. So that is the second one we got. I think we got the second one. Let's go with the other one. So that is third one. Let's say fx which is equal to x cube. Now let's try fx is equal to x cube. Then here in this case, we need to remember some of the points. We should understand that now we know, by now we know that dx by dx is equal to 1, we know, and then we know the d by dx to the power of x square is equal to 2x, we know. And now the last one is d by dx x to the power of 3 means what? Yeah, that's what we are trying to find out, friends. So here you see fx is equal to x cube, whereas dx by dx here is equal to 1, we know. D by dx square, we got 2x here, we got. So now let's go with this one. Okay, so now with this, when we go, then we know f x plus h is equal to, we have to make it cube now, because now here is that's cube, and we know here, so f prime x is equal to limit h tends to 0, we know the function f x plus h minus fx by h. That's what it is. Now we are replacing the values, and then here we get limit h tends to 0, we get x plus h whole cube plus minus x cube by h. So if we make it this again, limit x tends to 0, limit h tends to 0, what we are getting is x cube plus 3x square h plus 3x h square plus h cube. So that's the, and left over is x to the power of 3. So x to the power of 3 and positive and negative, they can be cut off. Here we have by h. So now let's see what is left over. We get limit h tends to 0. What we get is 3x square h plus 3x h square plus h cube by h. So that's what we got till now. Now let's see the last one. And now we further simplify by bringing this h in front. Then because h is common, we can take the h common and then cut. Okay, we can take it common and cut. So finally we get 3x square. What we get is 3x square. So the result over here is 3x square. So here we know limit h tends to 0 is 3x square over here. Okay, when we are doing this simplification, we are getting 3x square. So I think I'm clear here, my friends. Okay, so this is the simplification based on the first principle. So I hope if anything you have any doubt over here, you can just go on checking again and again. It's very simple, my friends. You can do it easily. try again and again, you will get it. So let's go with some other algebraic functions, my friends. So we have very important functions over here. So algebraic functions, okay. So with this algebraic functions also we can do very easily. So let's say limit x tends to a, then we have an equation x to the power of n minus x a to the power of n by x minus a is equal to n a to the power of n minus 1. So this is something like power rule, my friends. So but still you can just see algebraic equation, okay. So what is this equation says? In limit when x tends to a, then x to the power of n minus x a to the power of n by a minus x is equal to n a to the power of n minus 1. This is very important. Let's see this n1. We had left it this one. Let how do we get this above one? Let's say let fx is equal to x to the power of n. Now let's see this equation. How did we get? So here you see f x to the x plus h is equal to x plus h to the power of n. So like we did earlier, we are doing the same thing. Now replace this with the function. We know f prime x is equal to limit h tends to 0, where we see f x plus h minus fx by h. So now we have limit h tends to 0, we have x plus h to the power of n we got, minus x to the power of n by x plus h minus x. So that's what we got, my friends, here. So why did we get here x plus h minus x? Because here you can just see x plus h to the power of n minus x to the power of n, and then in place of h we have written here x. What does this mean? You know, this means this h. So you might be confused with writing this, because here we wrote x plus h minus x, means if you cut this and this you get only h. So in order to make it this equation in our limit format, in our function format, what we did is we have written x plus h minus x. It means only h, okay. So that's what we did here. So don't be confused with this. Now as we know h is equal to 0 here. So x plus h then is nothing but x. Then by adding let's see limit x plus h which tends to x, then we get x plus h, then what do we get? X plus h to the power of n minus x to the power of n by x plus h minus x, right? That's what we got, right? Where x plus h tends to x. Now we get the equation. Now what we get an equation. Yes, we get an equation which says, what does it say? What does the equation says? Now we get an equation where it says so here that is n x to the power of n minus 1. So that's nothing but we can say limit x to the a, we get x to the power of n minus a to the power of n by x minus a is equal to na to the power of n minus 1. So that's what we got, my friends. So that's what the equation was in the beginning. If we just check in the beginning, the equation that we wanted was the same one. When we are taking that x to the power of n, then we get this generalized equation. Okay, so now we got here, so all the algebraic functions we got for x, we got for x square, we got for x cube, and we got for xn. So for x we got one value, we got for x square we got 2x value, for x cube we got the value 3x square, and then for n we got the value, we know this equation, okay, this formula. Thank you. So for today this much. In next class again I'll explain further. Be tuned, my friends.